What's up guys? So we were talking about graphs in simple harmonic motion. I have already told you the graph of variation of velocity with x, and we were discussing variation of acceleration with x. So this is the graph for variation of acceleration with x coordinate. Okay, so this is the acceleration, this is the position. Okay, let's move on. Next is total force on the particle, and this will be basically same because force as a function of x is nothing but mass into acceleration as a function of x. So m into minus omega square x minus m omega square x. So now the slope will not be minus omega square but minus m omega square. So again a straight line with negative slope. When it is at minus a, then force is in the positive direction and the value is m omega square. When it is at plus a, then force is in the negative direction and value is minus m omega square. Okay, very simple. So minus m omega square a, I'm sorry, this is my minus m omega square into a. Okay, so let's move further. Now we have the variation of potential energy with x. So potential energy we know as a function of x is half k x square, and this is nothing, if you know a little mathematics, this is nothing but equation of a parabola. Okay, so this is equation of the parabola that passes through the origin. Okay, since the coefficient is positive, so it will open in the upward direction. This is the parabola. Okay, x is equal to 0, potential energy is 0, the spring will be uncompressed, and when the spring is elongated by a, potential energy will be maximum and value will be half ka square. Similarly, when the spring is compressed by a, then also the potential energy will be maximum and the value will be half ka square. Okay, so potential energy has no direction, it is always positive. So whether you compress the spring or you elongate the spring, if both these extension and compression have the same magnitude, then the potential energy will be same. Okay, so this is the variation of potential energy. Now kinetic energy as a function of x, we already know that the velocity as a function of x, it turned out to be like this. Okay, and kinetic energy is nothing but half m v square. If I substitute the value, we derive the expression that is half k half m omega square a square minus x square. Okay, and m omega square is nothing but k, so half k a square minus x square. Okay, so this is again a parabola only, this is also a parabola, but if you write it like this, half k a square minus half k x square, so the coefficient of x square is negative, so parabola will be in the downward direction. Parabola will be in the downward direction like this, and when x is 0, if you put x equal to 0, then y is half k a square. So at x is equal to 0, y is half k a square. When x is equal to plus a or minus a, then y is equal to 0. So when x is plus a or x is minus a, y is 0. If you see that this graph is nothing but um, you know very similar to the graph of potential energy. The potential energy graph was also rising to a maximum value of half k a square, but that value was coming out at minus 1 and plus minus a and plus a. So let me draw the graph here only. This is the variation of potential energy. So this is potential energy curve as a function of x, and this is kinetic energy as a function of x. Okay, and the sum of potential energy and kinetic energy will be constant. So at any particular x, let us say at any x, this will be the potential energy, and this will be this total will be the kinetic energy, such that the sum of kinetic energy and potential energy will be nothing. If I take this potential energy and I put it here, the total value will be equal to this value, which is half k square. So the total energy remains constant at any particular x. The potential energy added to the kinetic energy is a constant. Okay, so if I draw separately, total energy as a function of x is nothing but half ka square. So the graph will be like this. This is half ka square. Y is equal to half k square line. This is x-axis. So total energy remains constant, but we have to draw it between minus a and plus a, because that is the minimum and the maximum amplitude of the SHM. Okay, so we have successfully drawn all the curves: variation of velocity, kinetic energy, potential energy, force, acceleration, and velocity. So we have drawn all the curves, and in the next video lecture I'll be telling you the variation of uh, these quantities with time, how they vary with time. Okay, so stay tuned and we'll meet in the next video lecture. Have a nice day. Thank you.